Now each of our degree measurements have also what we call a radian measurement. So just as you can take and convert different lengths into, say, inches, feet, and so on, we can convert degrees to what we call radians. All right? And so you think about like the circumference of a circle. All right? So the actual formula for the circumference of a circle is 2 pi times the radius. All right? Now if you think about the circle, that the most basic circle is what we call a unit circle, moving all the way around, again, where this is the coordinate 1, 0, 0, 1. You can see that I know that this is called a unit circle because going from the center to any point on the graph, all right, from here, any of these are called radii, and that gets me a length of 1. And so if I do that, then what we consider is that one full rotation. That means that my radius is 1. All right? And I'm making one full circle. And if that's the case, 2 pi times 1 means that the circumference of the circle has the value of 2 pi. And so if I move all the way around from here, all the way around in a full rotation, the value is 2 pi, just like it was moving one full rotation was the same as 360 degrees. And so what we can do is we can actually change all of these to their radian counterparts. All right? So starting from here, 0 degrees and 360 degrees. All right. Well, that's the same as saying 0 radians. And so when we're talking about radians, we're not going to use this symbol. All right? So this is the same thing, like I would say, 0 is the same thing as 2 pi. All right? And so that's what we look at in terms of a radian measurement. That's the same thing as 0 and 360. So if I take what we call the 2 pi and I cut that into halves, so half of 2 pi means that over here at 180 degrees, the symbol that we're going to use to show degrees and radians is pi. So when we talk about pi, that is a number that we've talked about before, about in terms of like 3.14 and some change. But when we talk in terms of degree to radian conversion, 180 degrees is in the same place on the unit circle as the pi symbol. Now if you take 2 pi, right, it's easier to do on a calculator. If I end up taking, say, 2 of those pi's and I cut 2 into quarters, all right? So 2 of those pi's cut into quarters is half. And so if I think about 2 pi divided by 4, this pi symbol is still going to be here, which means this is the same thing as pi over 2. So if I think going from 0, I have 1 pi over 2, 2 pi over 2. That means this is the same as 3 pi over 2. And 4 pi over 2 is the same thing as 2 pi. So all of your fractions have to simplify. You have to think about, again, just multiples. Just like we did with degrees, you have to think about taking one small portion and multiplying that by how many of those equal portions. So to get up here, I have half of a pi, a full pi, 3 halves of a pi, and 2 pi. And so let's look at how we're going to chop these up. All right. Again, if I have 1/8 of 360 is 45 degrees, well, 1/8 of 2 pi is considered pi over 4. And so again, I'm just taking this 2 pi and cutting up into 8 equal portions, and you can see this is the full rotation, this is the portions that I have, and this is the notation. So to get to 45 degrees, that's the same thing as calling it the radian measure, pi over 4. So 1 pi over 4, 2 pi over 4, 3 pi over 4 is the same thing as 135 degrees. Okay, again, pi is at 180, which is 4 pi over 4, 5 pi over 4, 6 pi over 4, which has to be simplified, and 7 pi over 4. And to get all the way over here is 8 pi over 4, which is again the same as 2 pi. And so we can go through and we can label our larger one also. Okay? Again, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4, 5, 6, 7 pi over 4. Okay. And so all of those measurements in the center that are 45 degrees have also a radian measurement as well. And what you want to be able to think about is, again, positive radian measures means that we go in a counterclockwise position. Negative radian measures would mean that we went clockwise. And so all of these terminal angles have both a degree and a radian measurement that they are named by. If I go over here and I think of taking 2 pi and I cut that up into 6th equal portions, that's the same thing as pi over 3. So each of these increments are going to be in pi over 3 increments. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4, 5, and 6 pi over 3 gets you back to the circle. Okay? So I can do the same thing over here at the 60-degree marks, which has equal portions of pi over 3's. So 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, and then all the way back again. All right, so the 60-degree marks are in equal portions of pi over 3 increments. And then again down here, the 360, if I take the full rotation kind of name or measurement for radians, which is 2 pi, and I multiply that or cut that into 12 equal portions, that's the same as pi over 6 increments. All right, so 1 pi over 6, 2 pi over 6, 3 pi over 6, all right, 4 pi over 6, 5. And you can see some of these are being simplified. You must always simplify your fractions. 7 pi over 6, all right, 8, 9, 10 pi over 6, 11 pi over 6, and then 12 pi over 6 gets you back. So we can label all the pi over 6 increments as well. All right, and so you're going to see that some of these are, again, already labeled because they are multiples of the 30. And every time you have a multiple of the 30, you're going to simplify that fraction down. So not every one is going to get labeled. All right. And so these are our radian measures.